Okay, this is the chapter 4 test review. So we're going to sketch a graph given the situation. So I'm going to draw my x and y axis. My distance traveled depends on the time. And for here, I'm going to call the distance traveled how far I am away from my house. So if I ride my bike, I go at a pretty steep speed. And then I stop for a while in the park. So that's where there's a flat line there. I'm not going away from my house. But notice how when I'm going back, I go faster back towards my house. So it's steeper because I'm taking less time to go back to my house. So that's why it's gonna be a little bit steeper there. It's not the same slope there. All right, let's look at number two. So here I want to identify the independent and dependent variables. And here, usually the first variable you're giving is the independent variable. The second would be the dependent. But in this case, my speed or my velocity, since that's the title of my graph, it depends on the temperature. And notice how the temperature increases by 5 degrees increments. The speed increases by 3 meter per second increments. So I identified those. I can say that the velocity goes up as temperature goes up, and I can be more specific with those values. I can graph and plot those values. Now to find the equation, it might take a little more time, but notice how my velocity goes up 3 every time my temperature goes up by 5 degrees. But there's not like a direct variation here. So in order to find what little thing I have to add on to that in addition to the 3 over 5, I can just work backwards and go from, okay, if they increase by 10, if they increase by 5 and 3, I can just work my way backwards. And whenever the temperature is 0, I get a speed of 331. Or here's another thing I can do. What I can do is I know that the speed goes up 3 every time temperature goes up 5, so that's 3/5 t. I can use y and x if I want to, I can just take any ordered pair. In this case, I take the first ordered pair in the table, 10 and 337, plug it into those values of t and v, or x and y if you wanted to use those instead, and I can solve for that little bit that I scale up, and again I get 331. So finding that equation is there's several ways you can do that. You can even guess and check if you want. Here I'm going to see if these points are linear. I'm going to plot those points. So left 3, down 5, left 1, down 1, up 1. Right 1, up 3, right 3, up 7. And you can see I can easily connect these points with a line. Therefore, it's linear. I can also check that it's linear in another way instead of graphing. I notice that every time the y's go up by 4, the x's go up by 2, and since that's consistent all the way through, that's another way to check that it's linear. We talked about slope before, so you can even check the slope, but you don't have to know about the concept of slope just to see if it's linear if you're using a graph. The next one, I'm going to just plot these points in a graph, and I'm going to notice that when I plot just 3 of those points, it gets kind of curvy. No one line can go through those 3 points because it just kind of curves. Now, I should be able to recognize this. I think this is probably the graph of a parabola. I'm not given the rest of the equation, but I would guess if I graphed the left side of that, it would be a parabola. But I can tell regardless because of how they change. There's not a consistent slope all the way through. This is not going to be a linear equation. In this next one, I'm going to make a table of values for these function rules. So I can choose smart values here. The 1 and the -1, when I actually plug those in and show my work for those, I'm going to get decimal values, and those are not as fun to graph. Decimal values is harder to graph that. So instead of graphing those, I noticed that instead of picturing this as 1.5x, I could picture it as 3 over 2x. And since there's a fraction with a denominator of 2, the only x values I really like are the ones that are multiples of 2. And so when I evaluate and find those y values, they give me nice whole numbers. And you want to plot 2 points is enough if it's a linear function, but you want to plot 3 just in case. It makes your line a little bit more straight. So I'll plot those ordered pairs, -2, -6, 0, -3, 2, 0, and I can connect those with a line. If I plugged in even more of the x values, you would see that it would still go through these points. I can also, you don't have to know this yet, but something we've done in class, you can use the slope trick and just go up 3 and over 2. But it's better to just do it with tables for now, since we're more familiar with that. This next one, I should know right away this will be a parabola shape and not a line. Again, I can just plug in values of x. I always like to choose some positive values, some negative values, And whenever you're doing it with the negative values, especially, notice that you should square the value first, then incorporate the negative. So here I'm going to square the -2 first because of order of operations, then incorporate the negative. So -4 plus 4, this will come out to a value of 0. So that's not going to be 8, that's going to be 0 as the y value there. And I can just evaluate all my other values the same way. Again, I'm showing my work there if you want to pause and look at that. But all these values should check out. I plot those points. I notice that this is not a straight line. And because it's an x squared equation, you should know that this is a parabola. I only care that you graph this part really accurately. After that, I'm just going to kind of sketch the little tails that go on. Again, I'm doing that ugly on purpose. Just do a rough sketch of them, and I'd be happy. As long as you have your points plotted right and you know that that's a parabola shape in general, that's what I care about. Here we want to find the domain and range of these relations. So we're given them as ordered pairs. Domain, I want you to connect with x values. Remember, domain, x values. You can put those in ascending order or not. If you put them in the wrong order, I won't take any points off as long as you have all the x values accounted for. For the range, there's some repeat y values. The y appears twice. You do not need to write the 6 twice. If you do write it twice in the test, I won't penalize you for it. I'll just cross it out and remind you that you don't need to. But when something's a function, we're asking this. If you ask it one question, the x value, you should get only one answer, the y value. You notice that even though the y values repeat, the x values don't. So for each x that I ask a question about, it only gives me one particular y for that x, even though two of them have the same answer. Like if you have to ask this function either 8 or ask it the question 5, those x values, they do give you the same y value, but it is still a function. For this next one, I notice here, instead of them having repeat y values, they have repeat x values. Now that's going to be a problem. Again, you can put your domain in order. It's just your x values. You can put your range in order too if you want. But when I go to do a mapping diagram of this, I notice that, okay, the -3 maps to 8. The +3 maps to 8. I notice that the 4 maps to 9.5. And here's where I'm going to get an issue. The 9 maps to 6, but it also maps to 2. So if I ask it the question, hey, what is y when x is 9? Well, it gives me two answers. It says, well, y is 2. Wait, no, y is 6. Wait, y is 2. Wait, y is 6. So the x values are not allowed to repeat. That is not a function. Number 9, we're writing an equation out of this situation. So we start with a full bottle, 48 teaspoons. We lose 2 teaspoons every time we cook a batch of cookies. So if we cook 2 batches of cookies or one more batch of cookies, you go from, you lose 2 more tablespoons. So every time you cook a batch of cookies, you lose 2 tablespoons. So I can do, the function is V vanilla is equal to 48 minus 2 times how many batches of cookies I cooked. I use C for the variable, but since they specifically said use B for the variable, I'll go ahead and swap that. And you'll notice the first one I wrote just with the V. The second one I wrote in function notation. I really don't care. You don't have to write it in function notation, but I want you to be able to recognize function notation. That way, when they ask how much is left when you do 12 batches of cookies, you can plug in that 12 right there, and you can get that result 24. Number 10, we're buying party favors. Party favors, they cost $2.47 each. Now, since I can't buy half of a party favor, I'm gonna plot this in a discrete way. These are gonna be kind of separated. So you could think of your range as, well, I can spend between $0 and $30, but if I actually plug in the values, like I can only buy integer levels of party favors. You can't buy 2.5 party favors. But the idea is it's $2.47 for each party favor you buy. I can calculate those easily using a table in my calculator. You don't have to use the table version of your calculator, especially if you don't have a TI-84. You can just, if you want to, like multiply these values. But I care that you understand that you can buy between 0 and 12 of these party favors. Now, why can't we buy 13? Well, once I calculate the values for this at 13, I notice that I actually go over $30. So you actually go to, once you buy 13, you spend $32.11. Since my cap on spending is only $30, I'm not going to include that in your range. So between 0 and 12, just the whole numbers there, and between 0 and $29.64 is my reasonable range for those party favors. For this next one, we're given the domain. We want to find the range. Since the domain is these specific 5 values, I expect to have probably 5 range values. And we'll talk about when it's possible you might have fewer. But all I do is plug in those x values, those domain values, into my function, and I'm just individually calculating this. I'll show you, you can calculate these by hand. That's fine if you want to. But also you can calculate them by running them into your calculator. I just care that you show you plugging that in and showing those values. But my range is going to be that assortment of range values I got from plugging those domain values in. Here, again, plug these into the other function. This is the function for number 12. I'm plugging those domain values into the x, calculating them individually, and you can calculate them on your calculator by just by your calculators do order of operations. But let me show you something else it does. You can just type exactly what it says here. It will square that, then multiply the 5, then add the 4, and you get 24. And I can do this for all these other values. And something that's even neater with your calculator is you can type in a value, okay, and calculate it. Now, instead of retyping the 5 and the 1.5 and the squared, I'm going to scroll up. I'm going to grab that equation, and I'm just going to like recopy it. And I'm going to do it again for the 11. I'm going to scroll up and like recopy that. I'm sorry, I don't have to do it for 11 here. But I can scroll up and recopy it and retype my x values. And since 84 appears twice, I don't need to actually type that range value twice. For this next one, we are talking about sequences. I want the second, fourth, and 11th term of each of these sequences. All you do is plug 2, 4, and 11 into these equations, and that gives you the value right there. I can make my calculator do all the work, scroll up, replace the 2 with a 4, replace the 4 with an 11. I can use second insert to type those, and there's my values. You could also do that by hand, but those are your 3 values. For number 14, all you have to do is find the second, fourth, and 11th term of the sequence. Again, we're just substituting 2, 4, and 11 in place of n. N stands for like 1 stands for the first term, 2 stands for the second term. All I'm doing is substituting those values. Here, we're going to find a formula to represent each of these sequences if it's arithmetic sequence. Number 15 is not because it doesn't change by the same amount each time. Number 16 does change by 0.25 each time. The first term is 3, and then it increases by 2.5 each time. So a recursive way of saying that is the current term is the previous plus 0.25, whereas my first term is equal to 3. The explicit way of saying that is given by this formula here. What I would do is I write my first time plus n minus 1 times how much I'm changing by each time. That's the explicit way of writing those. So you have recursive, the first one, and then explicit, the second one. All right, for this one, all I'm looking for is, are these going to be represented by continuous or discrete graphs? Since pounds, which is a unit of measurement, I can have half a pound or a fraction of a pound. That's more likely going to be continuous since you can change your weight, like you can transition all the way through those numbers. Whereas the second one, you can't buy half a flour. So if I want my profit, since I sell them for $1.50, sell them for 80 cents, or sell them for $1.50 and they cost me 80 cents, I make 70 cents profit. So it's more likely to be a discrete function. You're not going to sell anyone half a flour in this situation. Versus the first one, you could sell someone half a pound. Here, we're just brainstorming. Is there an example of a function that can have an infinite domain but a finite range? Well, yeah. Say you have a car and it's going 60 miles per hour. It only has one speed. You have infinitely many points between 9 and 10, but only one range value. And specifically, they don't ask for this, but the equation of this function would be just y equals 60. Notice how there's no x in there because your range is always 60. For number 20, we're trying to see, okay, is there a difference between a relation and a function? Relation is just it relates two different variables, two different types. We did a lot of examples. We talked about temperature and speed of sound. We talked about some other examples, but it's relating two things. Here's what to remember when it's a function. It's a function if the x values do not repeat. And the second one, the x values repeat, so that one's not a function. And you can look at this summary to be reminded of what this is. All right, that's it for the content on this test. Do your best and study well.